We often see cosmetics as these simple everyday items, a swipe of lipstick, a dab of cream. But peel back that surface and you'll find a surprisingly complex world where science, regulation, and the amazing machinery of our own bodies all meet.
That's absolutely right. What sits so casually on a store shelf is often the result of really intricate formulation and, well, a deep understanding of how different ingredients interact with our skin, our hair, our nails, all that stuff.
And that's exactly what we're doing today on the deep dive. We're plunging into the science that powers our cosmetics using some fantastic material that you, our listener, sent our way. Excerpts from the Handbook of Cosmetics.
Yeah, these excerpts give us such a great, wide-ranging look at the field. They cover everything from, like, the basic definitions of what even counts as a cosmetic, all the way through to how these products are designed to work with specific parts of the body, what makes them safe, the role of all sorts of ingredients, and even the really clever ways these formulations get delivered.
Okay, let's unpack this. Our mission today is to really dig into this wealth of information and pull out the most fascinating and, well, genuinely useful insights. We want to help you understand what's going on behind the scenes in the cosmetic world without feeling like you need a chemistry degree.
Definitely.
So, with this hefty handbook in front of us, where should we even begin?
A really logical place to start, I think, is by getting a handle on what we actually mean by cosmetics when we talk about them in a regulatory sense. Handbook lays out these definitions.
Okay.
And one of the first things that jumps out is that the lines between drug and cosmetic aren't nearly as clear-cut as we might assume.
Exactly. It's not like a product is either one or the other, is it?
Not at all.
The handbook makes it clear that a product can legally be classified as a cosmetic, a drug, or
Yep.
even both at the same time. Here's where it gets really interesting. If a product is intended to cleanse or beautify, but also has the purpose of treating or preventing disease, or if it's meant to affect the body's structure or how it functions, then under the law, it's considered a drug.
Precisely. And this dual classification leads to some really common examples that you probably have in your own bathroom right now.
Like what?
Well, think about toothpastes that contain fluoride to prevent cavities.
Oh, right.
They're cosmetics because they clean your teeth, obviously. But the fluoride means they're also drugs because they're actively working to prevent disease.
Okay, that makes sense.
Hormone creams are another good example of this overlap.
And it doesn't stop there, does it? The handbook mentions sun-tanning products that also contain sunscreen.
Right. If they make claims about protecting you from the sun or helping you tan, they fall into both categories.
Then you've got antiperspirants and deodorants. Antibacterial soaps, the ones that kill germs.
Yeah, and even shampoos designed to treat dandruff. It's quite a list of everyday items that exist in this kind of a in-between space.
So what about this term the handbook uses, new drugs?
Ah, yeah, that's fascinating. It explains that if a product in this dual category contains ingredients that aren't generally recognized as safe and effective, JOSHO, that's the FDA term,
Grace.
or if those ingredients haven't been used materially, for a significant amount of time, then the product might be classified as a new drug.
And that...
In those cases, the company making the product actually needs to get approval from the FDA through what's called a new drug application, or NDA, before they can start selling it.
So even something you just grab off the shelf at the pharmacy might have gone through a really rigorous approval process, the kind we usually associate with prescription meds.
Exactly. It definitely makes you look at those product labels a little differently, doesn't it?
It really does. Okay, so once we actually use these cosmetic or dual-purpose products, they have to interact with our bodies.
Yeah.
The handbook goes into some really fascinating detail about the barriers they encounter.
It does. And understanding these barriers is absolutely key to understanding how cosmetics work and sometimes, why they might not work as well as we hope. Let's start with the skin, which, as you know, is our largest organ.
Right.
The handbook uses a really helpful analogy here, comparing the very outermost layer, the stratum corneum, to a brick wall.
Okay, I like that visual. So the bricks in this wall are the flattened, kind of dried out skin cells on the surface.
Exactly. They're called cornified cells. And the mortar that holds these bricks together is this rich, oily material, intercellular lipid material, technically, that's secreted by little structures called membrane-coating granules in the layers of skin just beneath.
Ah, yeah.
And this mortar is the main barrier that controls how much water can pass in and out of our skin, the permeability barrier. Crucial for keeping us hydrated and also for preventing all sorts of substances from easily getting into our bodies.
So the key thing for you, the listener, is that your skin is a really effective barrier. Most stuff you put on it has a tough time getting through, which helps explain why some cosmetic claims might, well, sound a bit too good to be true.
That's a very good point. It's our body's natural defense.
And what about the spiny appearance that the handbook mentions in the stratum spinosum? That's a layer just below, right?
Yeah, just below the stratum corneum. That refers to the intercellular bridges, or desmosomes, that connect the cells in that particular layer. Under a microscope, these connections actually look a bit like little spines sticking out between the cells.
Huh, interesting. Okay, moving on to our nails. They often seem pretty basic, but the handbook suggests their structure is actually quite complex.
It really is. The nail plate itself is described as being like a regular woven fabric, a weft made of keratin filaments all tangled up in this protein-rich matrix.
Like a fabric.
Kind of, yeah. And if you look at it with an electron microscope, you can even see differences between the upper part, the dorsal part, and the lower ventral part.
Ow.
Well, the cells on the upper surface are flat and fit together like tiles, nice and smooth. Understanding this structure helps explain why nails are strong, but also a bit flexible, and why certain treatments might affect different layers differently. Like a strengthening treatment might target those anchoring knots we're about to talk about.
Okay, and the lower part is different.
Yeah, the cells in the lower nail plate are thicker, and they have these really intricate, almost finger-like extensions that interlock. The handbook calls them anchoring knots.
Anchoring knots.
Scientists think this structure contributes to the nail's elasticity and flexibility. It's also interesting that the handbook mentions those longitudinal ridges we often see running lengthwise down our nails, especially as we get older.
It's funny how something we often take completely for granted has such a complex microscopic architecture. Now, hair is another area where cosmetics play a huge role. The handbook emphasizes just how much hair can vary.
Oh, massively.
Yeah.
It's quite remarkable, really. Even though the basic structure of the hair follicle itself is fairly consistent across people, the actual hair fiber that grows out of it can have extreme variations: shape, color, thickness, even how much body hair someone has.
Yeah.
It varies hugely between individuals and ethnicities.
And the handbook also touches on the psychological importance of hair.
Yeah, that's a big one.
Yeah.
Our hair is so closely tied to our sense of identity, self-esteem.
Absolutely.
The handbook mentions the real psychological distress that hair loss can cause, affecting both men and women, especially because it's often linked to perceptions of physical attractiveness. And it notes for men, going bald can even lead to people thinking they're older than they are.
Right. So the handbook then dives into the hair growth cycle. This seems pretty key to understanding hair treatments.
Definitely. It outlines 3 main phases based on a diagram it describes. First, you have anagen. That's the active growth phase.
Anagen, okay.
During this time, the hair fiber is constantly being produced by the follicle, and it's also being pigmented, getting its color. It can last for years.
Then comes catagen, which is described as the regression phase. What happens there?
In catagen, things slow down. Pigment production decreases, cells within the follicles start to differentiate, and importantly, the dermal papilla.
That's the bit at the bottom.
Yeah, the little structure at the base of the follicle that's crucial for growth. It actually starts to shrink and move upwards along with the hair shaft. This phase is much shorter, just a few weeks.
And the final phase is telogen.
Yes, telogen is the resting phase. During this time, the dermal papilla sits right at the base of the permanent part of the follicle, and there's no visible hair growth happening on the surface. The hair is just sort of sitting there, waiting to shed.
And eventually it does, and a new anagen hair pushes it out.
Exactly. And the handbook stresses that if there isn't proper interaction between that dermal papilla, a specific area of the follicle called the bulge, then future hair growth in that follicle can be compromised.
Fascinating. It's this whole dynamic process happening constantly right beneath our scalp. The handbook also mentions ways to evaluate hair, like the phototrichogram or PTG.
Right, the PTG. It's described as a method that's pretty easy for patients, non-invasive.
Good.
And it assesses what percentage of hairs are in that active growth phase, anagen. It also gives an idea of hair thickness. Now, a traditional microscope is still the most precise for measuring diameter.
But the PTG is less disruptive.
Exactly. You don't have to pluck hairs or anything. Plus, it allows researchers to follow up on the exact same area of the scalp over time, which is really valuable for tracking changes, maybe from treatments.
And they mentioned a frontal window technique.
Yeah, sounds like a technical improvement to help get clearer images.
Yeah.
So these methods really help us understand the current state of someone's hair and, how it might be responding to different things.
Okay, interesting. Now, moving beyond how cosmetics interact with healthy skin and hair, the handbook also delves into potential unwanted interactions and sensitivities.
Yeah, this is a really important area, especially with just the sheer number and variety of cosmetic products out there.
Right.
The handbook starts by defining terms like acnegenicity and pustulogenicity.
Okay, let's break those down for you. Acnegenicity, that refers to the ability of something, an ingredient or a product, to cause those tiny plugs, microcomedones, inside hair follicles?
The precursors to blackheads and whiteheads.
Exactly. And this usually happens relatively quickly after exposure.
And pustulogenicity describes the capacity of an ingredient or product to trigger the development of inflammatory papules and pustules. The red bumps and pus-filled spots we usually think of as acne.
Got it. Then the handbook moves on to the really common concept of sensitive skin.
Ah, yes, sensitive skin. We hear that phrase all the time, don't we?
We do. The handbook highlights that it's really defined by consumers themselves as a kind of intolerance
Right.
to various things we put on our skin, including cosmetics and even some medications. People who say they have sensitive skin often report sensations like burning, stinging, itching, or tightness when they use products that don't bother most other people.
And sometimes you might even see visible signs like redness or swelling, erythema, or edema.
So what's causing it?
Well, the handbook outlines several potential mechanisms. It suggests the more common ones might be sensory irritation, where the nerves just react more easily, and so erythematous irritation, which is like a low-level inflammation that isn't quite red yet.
Okay.
But it could also be things like acute irritation, cumulative irritation building up over time, contact urticaria, which is like hives,
Right.
and various forms of contact dermatitis, including allergic reactions, photoallergic ones triggered by sunlight, and phototoxic ones also involving sunlight but not the immune system.
Wow, it sounds like a really complex issue with a lot of potential triggers, which naturally leads us to the question of how these ingredients actually get into and through our skin. The handbook has a section on percutaneous absorption.
Percutaneous absorption. Yeah, it's described as a sequence of steps. Starts when you apply a product,
Okay.
and the chemicals in it begin to move or partition from the vehicle, the cream or lotion base, into the skin layers.
Partitioning, like
Yeah.
moving from one phase to another.
Exactly. Then absorption and excretion processes begin,
Yeah.
influenced by all sorts of factors: the person, the body area, the product itself.
And once these chemicals are absorbed, the handbook says they can actually get into the bloodstream, systemic circulation.
They can, yes.
Yeah.
And their behavior once inside is governed by pharmacokinetics, basically, how the body handles and gets rid of substances.
Right.
They even use hydroquinone, the skin lightening agent, as an example. It can reach almost its peak concentration in blood plasma within just 30 minutes of being applied topically.
Wow, 30 minutes? That's surprisingly fast.
It really is. It highlights that even stuff we put on the surface can have effects beyond just that local spot.
Hmm.
And this brings us to that somewhat blurry line between cosmetics and pharmaceuticals, especially with the rise of cosmeceuticals.
Cosmeceuticals, active agents in cosmetic products.
Right. The handbook uses hydroquinone again here. Legally, whether it's a drug or cosmetic, often just comes down to its concentration.
Just the percentage.
Pretty much, yeah, legally speaking. But what's really crucial for figuring out potential risks is its bioavailability, how much actually gets through the skin.
Okay.
The handbook cites studies showing around 45% of topical hydroquinone can be absorbed in 24 hours. That really underscores the point about bioavailability being key for risk assessment, regardless of the legal category.
Absolutely. It makes you wonder, at what concentration does a cosmetic with active ingredients really start acting more like a drug, functionally speaking?
Exactly. That bioavailability data is crucial. Now let's switch gears a bit and talk more specifically about allergic reactions and irritation from cosmetics.
Okay. The handbook notes something interesting about sunscreens, that even though use has gone up, their contribution to overall cosmetic allergies seems relatively small.
Yeah, it's a bit counterintuitive. One possible reason mentioned is that contact or photoallergies to sunscreen ingredients might sometimes be mistaken for just being extra sun sensitive.
I could see that.
Another factor could be patch testing concentrations. Maybe the standard test amounts are sometimes too low to trigger a reaction in everyone who's actually allergic.
Right. And it's not just the active ingredients, is it? The handbook mentions excipients and emulsifiers, too.
Oh, absolutely.
Yeah.
Many common inactive ingredients used in both drugs and cosmetics can be potential sensitizers, things that cause allergic reactions.
Like what?
Examples given include wool alcohols, certain fatty alcohols, propylene glycol,
Hmm.
even common stuff like malleated soybean oil and cocamidopropylbutane, or maybe impurities from its synthesis.
So even the stuff that's just there to make the cream creamy could cause a reaction.
It can, yeah. Which is why proper patch testing is so vital for figuring out individual sensitivities.
This helps explain the push for hypoallergenic products then.
Exactly. The handbook says this involved trying to use raw materials with a low potential for sensitization, using very pure ingredients, avoiding known triggers like fragrance, and increasingly using physical sunscreens like zinc oxide and titanium dioxide, which are generally seen as less likely to cause allergies compared to some chemical UV filters.
It's all about minimizing risk. The handbook then differentiates between skin irritation and corrosion. Irritation is less severe, non-immunological.
Right, and it covers a whole spectrum, from reactions that are almost corrosive down to very mild effects.
And developing alternative tests for irritation has lagged behind tests for corrosion.
It seems so, yeah. Probably because corrosion is the more severe immediate concern. Currently, the handbook mentions the dryage procedure originally for eyes is often used for both skin irritation and corrosion, just with different exposure times.
But there's a push for human testing now, clinical patch testing.
Yes, for non-corrosive chemicals to get a more relevant assessment. Applying it to finished cosmetic formulas gets a complex, cost and time.
Sure.
But industry groups like Culpa in Europe have guidelines for human skin compatibility testing. And scientists are also exploring in vitro tests, lab tests, not on living organisms,
Right, the alternative.
as potential screening tools.
Yeah.
Quicker, maybe cheaper, to help prioritize what needs closer clinical study. So these tests are super important for assessing safety without animal testing.
Definitely a good thing. The handbook mentions the ECVAM program, validating some of these alternatives for corrosion like TER, Corcetex, Skin 2.
That's right. So progress is being made on validating alternatives.
Okay, so digging deeper into irritant dermatitis, the handbook defines it as localized non-immune inflammation.
Yeah, with objective signs like redness, swelling, maybe blisters,
Erythema, edema, vesiculation.
and subjective feelings like burning, stinging, itching.
And it can take different forms: acute, cumulative.
Right, acute from a single strong exposure. Irritant reactions from regular exposure, like hairdressers get. Contact dermatitis from repeated reactions, delayed acute reactions.
Yeah.
And cumulative irritation, probably the most common type, building up slowly from repeated mild exposures.
The handbook also briefly mentions some animal models, mouse models, used to study the mediators involved.
Yeah, looking at things like the tachykinin NK1 receptor,
Yeah.
and using biomarkers like Evans blue dye or myeloperoxidase to track inflammation.
And for human testing, things like the soap chamber test or arm immersion tests to mimic real use.
Exactly. Trying to get better predictions of how irritating a product might be in real life by simulating consumer exposure under controlled conditions.
Okay. Moving from skin to eyes briefly, the handbook covers eye anatomy: cornea, sclera, conjunctiva.
Yeah, the basics. The cornea at the front with its layers, vital for vision, the sclera, the white part, and the conjunctiva, that mucous membrane covering the front and lining the eyelids.
Understanding that is key for eye product safety.
Absolutely. And the handbook then introduces various in vitro eye irritation tests again, alternatives to animal testing.
Like using isolated eyes or corneas.
Yes. Tests like IRE and SEAT use isolated whole eyes, accepted for severely irritating stuff. Others use isolated corneas or multi-layered cell systems, or even just single-cell cultures.
Good to see those alternatives gaining ground. Now let's talk about the foundation of any cosmetic, the vehicle. The stuff that carries everything else.
Like the vehicle, it's the physical chemical system for delivery.
Yeah.
And its composition hugely influences things like solubility of the active ingredient, the product stability, how quickly the active gets released.
All crucial.
The handbook mentions a classification system by Youngier as a useful tool for formulation design, production, understanding these vehicles.
But it's not totally rigid.
No, the lines can be flexible, they evolve. What's more important than just the category is thoroughly characterizing the vehicle, its physical, chemical, biological properties.
Okay, so in formulating, the choice of lipids, fats, and oils is key.
Absolutely crucial. Like non-polar occlusive lipids, think mineral oil are great for moisture retention, but maybe don't feel as nice spreading.
Right, can feel heavy.
Whereas polar oils might spread easier but be less occlusive. Then you have the emulsifier system, often complex blends of surfactants with different HLB values.
HLB, that's the balance between water-loving and oil-loving.
Exactly. And you might use co-surfactants too, plus maybe polymeric excipients, big molecules to help keep the emulsion stable.
The handbook then discusses microemulsions. They sound quite advanced.
They are pretty sophisticated. Systems of water, oil, and an amphiphile, usually a surfactant and a co-surfactant, they form this single liquid solution that looks clear.
Optically isotropic.
Right. And ideally thermodynamically stable, meaning it won't separate, though sometimes kinetically stable is included to stays mixed for a very long time.
And the droplets are tiny?
Incredibly tiny, 10 to 200 nanometers. They can be clear liquids or gels. And yeah, they're being explored a lot for potentially improving skin penetration of active ingredients.
So the main goal is dissolving the active in the vehicle. If not possible, then using finely divided particles.
That's the alternative, yeah. And polarity is key for dissolving, dissolves like polar stuff and polar solvents, nonpolar and nonpolar.
Makes sense. And characterizing the vehicle involves looking at, lots of things.
A whole range. Macroscopic appearance, what it looks like, microscopic appearance, rheological behavior, how it flows, thermal behavior, chemical stability over time, preservative efficacy, biological effects on skin, and safety, of course.
And how it's made matters too. Mixing, dispersion.
Hugely. Those preparation methods significantly impact the final quality and homogeneity, how uniform it is.
And you check homogeneity by looking, using microscopes, measuring active ingredients.
All of the above. And droplet or particle size is also important for stability, measured using optical methods.
Got it. It also mentions multiple emulsions like water and oil and water.
Yeah, WOW or OWO. Two main ways to make them one-step conversion or a two-step process using different emulsifiers. The gentle mixing is key in that second step.
Complex stuff. These multiple emulsions can have unique delivery properties, which leads nicely into microparticles and vesicles for more targeted delivery.
Right. Microencapsulation, the handbook explains, is used for loads of reasons. Turning liquids into solids, keeping incompatible ingredients apart, masking taste in meds, reducing GI irritation, protecting sensitive stuff, improving stability, and controlled release over time.
Okay. And for skin cosmetics, microspheres for follicular targeting, aiming for hair follicles.
Exactly. Delivering actives right into the follicles. Advantages include stability, size control, protecting the active controlled release, and they can carry both oily and watery actives.
Versatile. And microsponge systems.
Yeah, those sound cool, tiny porous spheres that bind or trap substances.
Like little sponges.
Right, and they release them based on triggers, temperature, moisture, even rubbing the product on. You can put them in all sorts of products.
What about liquid crystals?
Also mentioned. Structured systems that could potentially enhance solubility and penetration, though one study cited showed more irritation compared to a microemulsion, so it's not always straightforward.
Interesting. And you can tweak microemulsions, add cholesterol or oleic acid to control penetration depth?
Apparently so. You could potentially target actives to stay in the epidermis or get deeper into the dermis.
And then these novel vesicles, ethosomes, and transferosomes.
Yeah, ethosomes are described as soft, flexible phospholipid bubbles. You can adjust their size to help deliver molecules into or through the skin, maybe targeting different layers or even going transdermal into the bloodstream.
Wow. And transferosomes.
Similar elastic vesicles, but with edge activators to further boost penetration. They also briefly mention niasomes made from non-ionic surfactants and their skin interactions. It's like a whole new level of delivery tech. It truly is. The handbook then moves on to some other interesting delivery technologies, starting with iontophoresis.
Iontophoresis using a low electric current to push stuff through the skin.
That's the one. How well it works depends on the active ingredients properties, the formulation, and the electrical settings, current density, duration, constant, or pulsed current.
Is it safe for cosmetics?
Generally, yes. Research suggests it's safe, with the main side effect being minor, temporary redness. Importantly, it doesn't seem to mess with the skin's barrier function much.
Good to know. Then it shifts to mousse technology.
Mousses, yeah, those light foamy products, defined as colloidal dispersions of gas in liquid or solid, usually from pressurized aerosol cans.
And they can be dilute or concentrated.
Depending on the propellant concentration, yeah.
Yeah.
Dilute have spherical bubbles in a viscous liquid. Concentrated have more packed polyhedral gas cells with thin liquid films between them.
Okay. And they usually come in aluminum cans.
Typically, yeah, with internal protective coatings.
Yeah.
The lining choice depends on the product inside. The handbook also explains how using a low-pressure propellant keeps waxes and fatty alcohols liquid while you rub it in, allowing them to recrystallize on the skin and do their thing once the propellant evaporates.
Yeah.
Slip agents like silicones help with rub-in and spreading.
Clever. Okay. From airy mousses to cosmetic patches.
Right. The handbook emphasizes that permeation for cosmetic patches usually means getting substances to their site of action within the skin.
Not necessarily systemic delivery like a drug patch.
Generally not, no.
Yeah.
And a key point, effective cosmetic patches need sound science, safety, and efficacy proof. It's not just actives on sticky tape.
Absolutely. Okay, so once these products are made, keeping them usable preservation.
Crucial. Protecting the product from microbes, bacteria, fungi before purchase and during use. Essential for efficacy, fragrance, appearance, stability.
It mentions trichlocarbon, TCC, in antibacterial soaps.
Yeah, a common one.
Yeah.
And notes formaldehyde was used in the past. Speed is important too. Preservatives need to act fast to stop microbes adapting.
And EDTA can help other preservatives work better.
Yes, it acts synergistically. It disrupts the outer layer of gram-negative bacteria by grabbing calcium and magnesium ions, letting other preservatives get in more easily.
And it's not just liquids. Even powders need preservation.
Apparently so, yeah. Though liquids and emulsions are obviously more susceptible.
Right. Okay, shifting back to skin interactions ingredients to help with irritation and inflammation.
A common concern. The handbook reiterates irritation is non-immune inflammation from external factors, chemical, mechanical, thermal, climate, UVIR.
All sorts. And it distinguishes acute versus chronic cumulative.
Yes, acute is usually a single, strong trigger. Chronic or cumulative builds up over time from milder, repeated exposures. Symptoms are the usual suspects: redness, dryness, scaling, itching, burning, tingling.
Objective irritation signs.
Right. And while strong irritants are easy to spot in tests, those milder ones causing cumulative effects need repeated application testing.
It mentions some potential anti-irritants: esculicide, ursolic acid, licorice, chamomile.
It does, but interestingly, it notes that when you do vehicle-controlled studies comparing the active in a base to the base alone,
Yeah.
often the specific anti-irritant effect is pretty small compared to the effect of the vehicle itself. It cites work on essential oils and glycolic extracts showing this. Suggests the base formulation plays a huge role.
That is interesting. So the vehicle matters a lot for how it feels and potentially irritation.
Definitely seems that way. And for anti-inflammatory ingredients to work, they need to be bioavailable in sufficient amounts at the skin level. Just being in the bottle isn't enough.
Makes sense. Then there's this concept of anti-sensory irritation.
Yeah, focusing on those subjective feelings: itching, stinging, burning, roughness, dryness, tightness, the stuff that really affects whether you like using a product.
So how does that work neurologically?
Involves specialized nerve endings, type C nociceptors, sending signals to the brain. It's distinct from sharp pain pathways, which use A-delta fibers. Strong sensory irritation can even trigger inflammatory mediators like substance P, leading to neurogenic inflammation, redness, swelling.
Wow. It gives an example with strontium nitrate and glycolic acid peels.
Yeah, showing it can rapidly inhibit sensory irritation without stopping the peel from working, stimulating skin turnover.
Cool. And flavonoids, like catechin, traditional anti-inflammatory use.
Right. Modern understanding suggests they can act as NF-B inhibitors, reducing pro-inflammatory gene activity.
Okay. And the antioxidant network, vitamins E and C interacting.
Yeah, it briefly discusses how non-endogenous antioxidants, ones we get externally, interact.
Yeah.
Vitamin E is a major chain-breaking antioxidant in membranes.
Stopping damage.
And it gets recycled by network antioxidants like vitamin C, ubiquinol, glutathione. Highlights the important teamwork between E and C.
Fascinating interplay. Okay, let's jump back to hair conditioners and treatments.
Right. The handbook uses M-images, scanning electron microscope pictures,
Ah, the close-ups.
to show hair damage. Raised, chipped, torn cuticle cells from washing and combing, and contrast that with the protective effect of conditioning shampoos, showing minimal damage.
So the cuticle state really matters for how much conditioning is needed.
Absolutely. Damaged hair needs more help. And the key ingredients are often cationic surfactants, quats.
Quats, because they're positively charged.
Exactly. Hair surface, especially damaged or towards the tips, tends to be negatively charged. Opposites attract. The quats bind, form a thin hydrophobic coating.
Making it feel softer, easier to comb, less static.
That's the goal. And interestingly, more quats deposit on more negatively charged hair, like bleached hair.
Makes sense. Preservatives are crucial here too, often used in combinations for broad protection.
Yep, need careful testing. Thickeners are also key for that creamy conditioner texture.
How do they thicken?
Several ways mentioned: liquid crystal formation with quats and fatty alcohols, using cationic conditioning polymers that also thicken, or adding agents like hydroxyethyl cellulose non-ionic. Works well with the cationic, stable pH, adds viscosity.
What about hydrolyzed proteins?
Commonly used, broken down proteins. They increase substantivity sticking to the hair, especially if modified with fatty quaternary groups. They can also form films for manageability, sometimes boosted with PVP polymer.
Any downsides?
Potential odor or color issues sometimes, requiring stronger preservatives.
Okay. Interesting that hair and nails have similar lipids to skin's stratum corneum cholesterol sulfate, ceramides.
And hair has that unique outer layer of 18-methyl-eicosanoic acid, making it water repellent.
The handbook also mentions choosing between liquid versus solid extracts for hair products.
Yeah, solid extracts spray-dried tend to be more stable chemically and microbiologically, but may be harder to get in clear formulas. Liquid extracts might be cheaper sometimes if long-term stability isn't the top priority.
Gotcha. And cellulose derivatives like CMC, HEC in shampoos for thickening.
Right. Water-soluble polymers that give that pseudoplastic or sheer thinning effect.
Meaning it's thick in the bottle but thins when you pour or lather.
Exactly. Useful for thickening shampoos, maybe reducing salt needed, and getting higher viscosity overall. Rheological additives in general are important suspending agents in many products. Emulsions, suspensions, foams, preventing settling.
Okay. Now, beyond just function, skin feel, sensory aspects.
So important for consumers. How it feels during use, rinsing, after drying. Influenced heavily by surfactants and conditioning agents.
And emollients and refatteners play a big role.
Right.
Lipids, oils, esters, silicones.
Yes, used in leave-on and wash-off products. They interact with the skin surface, affect how it feels. Getting them to deposit well from wash-off products is tricky because of dilution during rinsing, though.
Silicones are highlighted for that smooth, silky feel.
They are. Plus, they can be used in clear, water-based products. You can even blend different silicones for specific sensory profiles.
And humectants, like glycerin, attracting water.
Exactly. Hygroscopic, water-soluble things that pull moisture towards the skin. Glycerin is primary, often combined with others like sorbitol to reduce tackiness.
Right. Let's talk surfactants again, the workhorses of cleansing. Anionic, non-ionic, amphoteric.
The handbook compares them, noting non-ionics don't foam much on their own in shampoos.
So you add foam boosters, alkanolamides, amine oxides.
Often, yeah, to get that richer lather. Alkyl glucosides from fatty alcohol and glucose are mentioned as mild, with good foam stability.
And amphoterics, like betaines, used for mildness.
Yeah, often used with anionics or non-ionics to make the formula milder and boost foam. Some amphoterics even have an affinity for hair.
The handbook includes diagrams about surfactant aggregation and temperature and a phase prism diagram. It sounds complex.
Shows how these things behave in mixtures. Foaming itself is essential for many cosmetics, influenced by liquid viscosity. Surface effects like Gibbs-Marangoni, repulsions between bubbles, gas diffusion.
Lots going on in those bubbles. It lists examples of non-ionic and amphoteric surfactants and mentions emulsifiers like sorbitan esters, sugar esters.
Right, noting some like glucosides and saponins are natural origin and biodegradable.
Okay, super important category, sunscreens and UV filters. The handbook lists examples and their max allowed concentrations.
Yes, and points out the naming confusion, chemical name, trade name, OTC drug name, EU Annex 7 name, Australian AAN.
So INCI name is key for clarity.
Definitely the most consistent internationally. It introduces a newer UVA blocker, Mexrol SX tetrathalonine decamphor sulfonic acid,
Whoa.
saying it's comparable to avobenzone, and discusses physical blockers, titanium dioxide, zinc oxide.
They work by reflecting scattering UV.
Pretty much. They're inert, give broad spectrum protection, and micronanoforms are more cosmetically acceptable, less white cast.
Good. It also mentions panthenol forms, only D-form active, and vitamin C as an antioxidant.
Yes, ascorbic acid, potent antioxidant, involved in stopping lipid peroxidation.
Okay, cleansing bars versus liquids, soap bars made by saponification or neutralizing fatty acids.
Right. The handbook shows a flowchart. Bar formulation uses blends of long-chain fats, tallow, palm, and short-chain oils, coconut, palm kernel.
The ratio matters, like 80-20.
Yeah, higher short-chain oils give more lather, but the bar gets used up faster. Regular bars are mostly soap, plus water, glycerin, salt, fragrance, etc.
And it gives an example of a mild liquid cleanser, a silicynate-based.
Yes, paste-type facial cleanser, neutral pH, fresh afterfeel, listing key ingredients.
Moisturizers, again, evaluating efficacy. Kleeman regression tests. Visuals, desquamation, conductance.
Yeah, methods to see how well lotions work on dry skin, showing petrolatum often beats lanolin in prevention.
And important to use instruments like conductance meters alongside visual checks.
For a complete picture, yes.
Yeah.
though hydrophobic ingredients can lower conductance readings, so you need to interpret carefully. Expert sensory panels are also used for feel attributes, stickiness, greasiness, but require lots of training.
Right. Specific concerns: anti-cellulite and self-tanning products. Cellulite defined as that orange peel look from subcutaneous fat connective tissue.
Mostly affecting women post-puberty. Common spots:
Uh-huh.
buttocks, thighs, upper arms, knees, less often lower legs, back of neck.
Evaluation methods: calipers, bioimpedance, skin topography, ultrasound, thermography.
Various methods, yeah.
Yeah.
But standardization and visual grading can be tricky.
And self-tanning the DHA reaction with amino acids in the stratum corneum, forming brown melanoidins.
That's the mechanism, yes, a surface reaction.
Skin lightening agents, kojic acid mentioned, fungal metabolite.
Yes, works by suppressing tyrosinase, the enzyme needed for melanin production, by grabbing its copper. Well,
Used in Japan. Safety studies mentioned weak mutagen in bacteria, not eukaryotes, potential toxin induction, thyroid tumors in mice at high doses.
but no reported adverse effects from oral ingestion in humans noted. Potential for topical allergy, though. And one study suggested it works better in an anhydrous water-free base.
Interesting. Back to hair cosmetics, shampoos, styling, coloring, relaxing. Typical shampoo formula example uses ammonium lauryl sulfate.
As primary cleanser, yeah. Mild baby shampoos often combine amphoterics, betanes, sulfobetanes with non-ionic esters for less sting.
Styling gel mousses use polymeric film formers. Hairsprays create rigid joints between fibers.
That's the idea. Handbook suggests evidence for an epidemic of hair damage from treatments is lacking damage usually tolerated.
Tips to limit waving damage: acid sulfite waves gentler, acid rinse after alkaline wave, cysteine after sulfite wave.
Recommendations like that, yes. And waving before bleaching coloring is suggested, as waving's reduction step is harsher on oxidized hair.
Hair coloring categories: inherently colored temporary semi versus colorless precursors needing oxidant, permanent oxidative.
Right. Oxidative colors can also lighten natural hair, achieve any shade. Lots of methods listed for evaluating hair properties: combability, strength, static, surface, color.
Studies showing relaxers decrease wet strength. Thioglycolate milder than hydroxide.
That was reported, yes. Formulation concepts for fine hair: more quat polymer, less sebum uptake, and 2-in-1 shampoos, silicones, or other conditioners for conditioning without buildup.
And 2-in-1s work better on Caucasian hair, need more cationics for Asian hair.
That was noted, yeah. Performance can vary.
Oral care, periodontium, gums, ligament, cementum, bone, gingiva, gums, saliva components, salivary glands.
Basics of oral anatomy. General characteristics for anti-plaque agents. Broad spectrum, substantivity, sticking around, good taste, compatible, low toxicity, no ecology disturbance.
But sustained effect needs more than just killing bacteria. Retention, release, saliva influence matter.
Crucial factors, yes. It shows results from an in vivo plaque study comparing placebo to actives like CHDG, SNF2, triclose, alone with copolymers like Gantres, showed need for delivery systems like copolymers for triclose and retention.
Color additives and decorative cosmetics need FDA approval, except coal tar hair dyes. Unlisted colors mean adulteration.
That's the U.S. regulation, yes.
Mm-hmm.
Differentiates colors exempt from batch certification. Inorganics botanicals, 21 CFR 73, from those needing it. Synthetic organics, coal tar colors, 21 CFR 74.
Pigment extenders mentioned hydrated aluminum, barium sulfate, organic pigments, lakes, toners, true pigments.
Lakes are dyes precipitated onto substrates like alumina. Toners use other metals. True pigments are insoluble, most stable. Lakes can have pH stability issues, potential bleeding. Some organics restricted, like DNC red #36 in lipstick.
Pressed face powders like loose but with binders, soaps, kaolin, PE, Teflon. Binder level affects feel, compression, adhesion, color, water resistance, pickup.
All those things, yeah. Too much binder can cause glazing. Silicone-treated pigments for wet-dry use mentioned. Typical eyeshadow ingredients listed: talc, mica, kaolin, etc.
Basic mascara formula concept: solvents, waxes, resins, gellant, colorants, fillers. Example formulations for cream eyeshadow, waterproof eyeliner.
Gives you an idea of the components.
Antiperspirants, deodorants. Formulation involves vehicle choice for actives. ACH, ZAG, water-soluble, can be tacky. Siliconese esters reduce tackiness.
Yes, actives are acidic, so need compatible components. Issues with aluminum powders and anhydrous systems, white residue emollients, can minimize this.
Optimizing dry deodorant aerosols involves spray rate shape, particle size, concentrate propellant ratio, fragrance concentration, pressure.
Key parameters, yes. Hydroalcoholic pump sprays mentioned as an alternative, popular in Europe. Hygienic dosage, often use solubilizers like PEG 40 hydrogenated castor oil.
Baby and elderly skin needs: Baby skin barrier, immature at birth, high TEWL in preemies.
Stratum corneum develops late gestation. Cleansing inevitably degreases skin milder cleansers, less frequency important for elderly.
Facial cleansers for elderly, usually mild, superfatting. Surfactant-based ampholytes, betaines, or OW emulsions with superfatting agent humectants.
Tailored to be gentle and replenishing, yes.
Cosmetic regulations globally mandatory labeling notification in some EU countries, Denmark, Finland.
Mentioned briefly, U.S. FDA shares responsibility with FTC, advertising, CPSC, soap, child-resistant packaging, EPA, insect repellent cosmetics. Yeah, complex overlap. FDA regulates products labeling under FD&C Act. Key FDA role. Pre-market approval for color additives, except coal tar hair dyes. Batch certification for many synthetics.
Contrasted with Japan. Pre-market claim review, quasi-drugs category. CLS-listed ingredients meeting standards only need category license. Others need approval.
Different system, yes. Stability testing emphasized as continuous process from development through manufacturing changes. Formula-related reasons listed for stability testing, need for early screening.
Validated method for microbiological control described based on Europharmacopoeia. Sample prep counts, specific microbe investigation.
Standardized approach. Cosmetic claims categorized identity, function, safety, objective efficacy, varying global regulation. Objective efficacy claims need solid data. Biometrics in vivo vitro tests.
Yeah.
Skin reactivity changes with age, contradictory findings. Higher versus lower reactivity in elderly. Maybe deficient early warning system in older skin. Objective methods for assessing wrinkles as aging markers.
All discussed. Last topics. Comedone acne formation process. Plugs, sebum bacteria inflammation.
Yeah.
Oral malodor testing instrumental. Halometer for VSCs, and organoleptic, trained judges, smelling breath. It's truly a remarkably comprehensive overview of the science behind cosmetics. So much detail packed in there.
Okay, wow. Let's just take a moment to process all of that. This deep dive into the Handbook of Cosmetics has really illuminated just how incredibly complex and, frankly, utterly fascinating the science is that underpins so many of our everyday personal care products.
Absolutely. We've seen how even seemingly simple definitions like cosmetic versus drug can have layers of nuance.
Yeah, that overlap was surprising.
And the barrier functions of our skin, hair, and nails, they're far more sophisticated than we often give them credit for, aren't they? That whole brick and mortar analogy for skin.
Right. And those delivery systems, from these tiny microemulsions and elastic vesicles all the way to technologies like iontophoresis.
Yeah.
The level of innovation and just getting ingredients where they need to go is truly advanced.
It really is.
It's definitely been an aha moment for me, realizing just how much thought and, well, scientific expertise goes into formulating these products we often just slap on without a second thought.
And being well-informed in this area, I think, really means gaining an appreciation for these complexities, becoming a more thoughtful consumer, someone who can look at product claims and ingredient lists with a more critical and, knowledgeable eye.
Definitely. So here's a final thought for you, our listener, to consider. How does all this information we've discussed today change the way you think about the cosmetic products you use every single day?
Yeah, does it make you look at that moisturizer or shampoo differently?
Maybe it'll inspire you to take a closer look at those ingredient lists next time, with a newfound appreciation for the incredible science that's involved. And if any particular area we've touched on today, maybe microemulsions or sensitive skin mechanisms or hair structure has sparked your curiosity, we really encourage you to delve further. There's clearly a whole universe of fascinating science hiding right there in the beauty aisle.